All right, so officially you're welcome once again, and in today's agenda we are looking at loops. We'll talk about for loops, while loops, then do while loops. Then we'll look at functions, as well as take a look at some of yesterday's projects and how we're supposed to go by it. Last time, during last session, we ended with a bit of an introduction to loops after we have thoroughly discussed the concept of conditional statements. So we looked at using the if statement and using the switch statement. And before we ended, I made mention of the fact that these things, the conditions or the conditional statements that we dealt with, are things that we do to make the computer think for itself. So we make the computer make decisions on itself without needing us to always give it the command. So we've already pre-programmed, we've programmed the computer to take decisions. However, there are times or occasions that we want a particular decision to be taken continuously until a particular condition is met. So that is when the concept of loops comes in. We want the computer to keep doing something until a particular thing is done. So for instance, an alarm clock. We want the alarm clock to keep ringing until the user presses the snooze button. That is a loop. So far as the alarm clock goes on, keep on ringing until the person clicks the snooze button. Okay, so that is a practical or the practicality of loops as a concept in programming. You want to keep doing something until a particular condition is met. So you as a programmer will write as part of your program that your program should look out for a command like that. So keep on looping until the person presses the loop button. The person presses the snooze button. Otherwise, keep on playing the alarm. Okay. Last week, I was trying to come up with an example to explain something, and I think I may want to try it once more to explain the concept of loops. Before we get into the programming part, I want you to appreciate why we use loops in the first place, what they are, and why at all do we need them. Okay, so let's take this example. Let's assume that you, as an individual, have been tasked to go and check for, let's say, employees in your company, or let's select one employee and call that employee X. So we are looking at employee X. We know that the year of retirement of employee X is 60 years. We are assuming that. So this particular employee in your company will retire at 60 years. So until the person retires, every month you are going to be paying the salary of this person every month. Okay, every month you're going to be paying the salary of this person. So what you do is every single month you come in to come and check. Is your age up to 60 now? Is your age up to 60 now? If yes, I'll stop paying you. If no, then I'll pay you for that month. The following month you come again. Is your age up to 60 now? If not, let me pay you. If yes, I'll stop paying you. So you see, there is a decision that we are making there. We are making a decision as to whether we should pay the person or not. But this time around, we are not doing it once. So if you use the conditional statements alone, okay, that's which we learned the last time, using either the if statement or the switch statement. If you use just the if or the switch, you take a decision once. So you go and check, is a person 60 years yet? No. If not, pay the person. Then you pay the person. That's all. But we want this to keep doing it by itself. We don't want to every single time come and write an if statement. So go and do, after you do not get it, then write another if statement. No. We want that condition to be repeated for as long as this person is not up to 60 years. So what is going to happen is that you always going to check Well, we know these benchmarks. So after every month, we are going to check, are you 60 years? That's the condition we are checking for. If this person, so in the flowchart example, I should have drawn a flowchart well, but this is a condition. So that's how we represent a condition in flowchart. If are you 60 years? That's what the question I'm asking. If yes, so let's see if yes, or let me do the yes here. So if yes, what's going to happen is that I'm going to stop paying you. So what's here is stop paying a person. Okay. If no, then I'm going to pay you salary. If no, I'm going to pay you your salary. Then after paying you your salary, I'll come back another month. So I'm going to add another month. So plus 1 month. Then come back to check if you are now 60 years old. So basically, that's what is going to happen. Employee X enters this loop. We begin to ask, are you 60 years? If he is, we'll stop paying the employee. You are on retirement, so go away. If you are not 60 years, then we'll pay you your salary, pay the salary, then we'll give you another 1 month to come and check back on you. So we add 1 month to whatever age that you are already. So assuming that this person here was, let's say, 57 years old, then what it means is that when he entered this loop, we are going to go counting. So 57, we know that it takes 12 months to make a year. It means that we are going to run this loop 12 times. After 12 times, this person becomes 58 years. Please, it's a discussion, it's a group discussion. So at any point in time when you have a question, you can just pause me or mute yourself and ask your question. But please make sure you don't distract us with background noise, okay? And if you are not talking, don't unmute yourself. The moment you unmute yourself, you're either reacting to something or you're asking a question or you're passing a comment. In fact, let me make that clear as well, that I'm not the only one who is supposed to be teaching. We are all learning. So if there is any concept you think I didn't make it clear enough, or you have a different perspective about it, just unmute yourself and share with us. All right, thank you. So for up to 12 times, we'll be coming back every now and then. Then the age now increases to 58. We'll have to keep going. So we'll keep adding to another 12 times. So now we have gone like 24 times, and we have the 59. The next 12 times that will go, which will end up in the 36, will give us 60 years. So this loop is going to break, and we are no longer going to add the extra months. For that matter, we are going to stop paying this person. So that is how loops work, okay, or the concept of loops. A particular activity that is done, we are going to keep doing it until a particular condition is met or otherwise. So always, for any loop at all, you should have a condition that you are checking against. So there should be a condition for every loop. There should be a condition that you are checking. Then there should also be what will I call it? What would be the best thing? So something that changes. All right, so in the first place, there will be an initial value. Okay, so for every loop, there should be an initial value. Then we'll pass the initial value through the condition. We want to check if the initial value meets something. So here, this employee was 57 years old, and we came into the condition. So the 57 year is the initial value. Then we came into the condition to ask, are you 60 years old? Then the employee says, no, I'm not 60 years old yet. For that matter, the next thing is we need some sort of an increment, okay? It could be a decrement as well. I was trying to find the best way to call it. So it could be either an increment or a decrement, depending on what we want to achieve. So in this our case, it was every month. So we kept adding. So we'll add every month. This is very important. For every loop, we need three things. Three things for every loop that we are going to work with. The first thing we need is to set our initial value. Then we need the condition to check whether our initial value meets that particular condition. Then if it does not meet the condition yet, we'll need to do either an increment or a decrement. Okay, I hope that is clear. Now we are going to move to the types of
okay. No.
Yes, I know.
Please, can you go by those three things that is needed for the loop?
Okay, so I've said that for every loop, we need three things. Okay, for every loop, just bear in mind there are three things that you need. The first thing is you need a starting value. Okay, whatever you want to consider, there should be a starting value to it. So in the example that I gave, I said the person was 57 years old. So we were looking at age. Probably in our case of programming, we'll say you declare the variable age. Okay, let's say age is equal to 57. Then the next thing is condition. You want a condition, something to check your initial value against. So the condition here is, let's say, are you 60 years old? That's the condition we are checking with. And if this condition is met, then we are going to break out of the loop. The question is, are you 60 years if you are going to do something for you or not? If the person is not yet 60, we have to either increase the age. Okay, we increase or decrease. I'm saying decrease because there are instances. This one, because we are using age, we would rather have to increase it because age keeps increasing with time. Okay, but there are instances where we will need to decrease whatever parameter we are talking about. All right, so just keep it in mind. For now, you can keep it in mind that it is an increase, but we need these three things. It will make more sense when we start practicing them. Okay, and let's say we want to, let me give another practical example. We want our computer to count from 1 to 10. Okay, we want our computer to count from 1 to 10. Instead of writing, let's say print f1, then we can print f2, print f3. We don't want to hard code all of these things into our computer. So we want a computer to do it all by itself. That means that we have to use a loop. The loop will increase the value. So what we need now is our starting value. What's the starting value? We want to start printing from 1. Hence, our starting value is 1. Then what is the condition? We want to print up to 10. So I want to check if you have gotten up to 10. Okay, so my condition here becomes, is the value, so let me write it down here, that becomes a question. If I check for the first time and it's not up to 10, I want to go another round. So what I'm going to do is I'll increase the value. So increase the value by 1. Are we getting it? So let's assume that our starting value, we declared it to be a variable called x. We say x is equal to 1. Our condition is to check if x here is up to 10. So to say up to 10 in mathematics or programming language would use is less than or equal to. So what we are interested in here right now, condition is x less than or equal to 10? That is it up to 10? Okay. If it is not up to 10, then what do? We want to count an extra. So we'll add 1 to x. So our new x become equal to x plus 1. Now, this can be done once, but we want a loop. So what a loop will do is that, okay, so far as it wasn't initially up to 10, when you are done here, after adding the 1, go back and start again from the condition. Go and check this new x value. Check it inside the condition and see if it meets the condition again. So we started with 1. The first time we started with 1. It runs it through, checks, is 1 less than or equal to 10? It is not. I mean, it's not equal to 10. Okay, so it's less than, but it's less than or equal to 10. Yes, so it's within that. All right, it's within that range. For that matter, we'll go ahead and come to this step and add 1 to it. So our x now becomes 2. Then our loop is saying we should bring the new x, which is 2, back into this condition and check. Is 2 less than or equal to 10? Yes, it is. So go ahead and execute this. So we now bring our 2 here and say the new s is equal to 2 plus 1. So we get 3. 3 is still not, so we'll bring it up here, come and check the loop and say continue like that. So we'll get 4, 5, 6, 7, 8, 9. The moment we get 9, it comes here and check. Is 9 less than or equal to 10? Yes, it is. So go ahead and add. So it goes ahead and add 1 to it. We get 10. Then it brings a 10 back and say, is 10 less than or equal to 10? And that is true. It is less than or equal to 10. So this step, mind you, I think here it usually confuses people. The condition here, when it's satisfied, when we start implementing them in code, you understand. But pay attention here. The condition here, when it's satisfied, now we have 10. So the condition becomes, is 10 less than or, sorry, I didn't mean to write it this way. Is 10 less than or equal to, so less than or equal to 10? It is true. Once it is true, it will still go ahead and execute the increment. So we'll now have 10 plus 1, which is 11. So it will print our 11. Then it will bring the 11 here and ask again, is 11 less than or equal to 10? That is false. Now we have exited the loop. Initially, I was planning to print from 1 to 10, but I ended up printing from 1 to 11 because my condition that I was checking was wrong. This means that I was supposed to check if x is less than 10. That was all I was supposed to do, and not less than or equal to 10. Okay, so let's take note of that. We would appreciate it. Any questions before I start the actual loops? Any questions? Yes. Or any comments? Comment, suggestion, anything? Okay, so for now, let's go on. The two loops that we want to start with are the for loop and the while loop. So let's tackle the for loop. Even though there are some slight differences between them, they can basically be used for doing the same sort of things. Okay, so all you need to do is to master how to use them. Then you find the one that you feel most comfortable using, then you stick to it. But it's ideal that you use both, because I think sometimes one comes in handy more than the other. So if for anything at all, make sure you know how to use both of them. The for loop. So when you take any concept in programming, the first thing you want to know is how is this implemented. Now we know the idea behind loops or what loops are and how they work. But for this specific for loop, how is it implemented? And I've mentioned that there are three elements that the loops always require. There are three elements that loops always require. So what are those three elements? We need an initiator. Let's assume that the same program that we were working with. So x is equal to 1. Our condition, now let me update the condition to give us the right thing. So our condition is to check if x is less than 10. Then the increment is plus 1. So our new x is equal to x plus 1. This can be rewritten as x plus plus. So using the increment symbol, x plus plus. That means add 1 to x. Okay, so that is also allowed. For that matter, we have x is equal to 1. We have x less than 10 as our condition. And we have x plus plus. These are the three important aspects that the loop needs to take. So now we want to know, if you take a for loop, where do we place each of these? So every loop needs to have them, but where you place them is different for the specific type of loop. So for a for loop, we place them this way. You write your for with your space. Because of Betty styling, you leave a space between them. Then the first thing is, what is your initiator? Okay, so x is equal to 1. You start with that one. Introduce your semicolon, followed by the condition x less than 10, also semicolon, then the increment value. So that is the structure of the for loop. For loop is always like this: starting value, semicolon, condition, semicolon, then increment or decrement, depending on which you are doing. Yes, is someone asking a question?
Yeah, for the x lesser than 10, did you omit the equal sign, or this is what you intended to?
Yeah. So
okay.
From the previous step, I realized that the equal sign there was giving us more than 10, and we needed to print up to 10. So I want it this way. We'll see it when we start practicing it, and I'll explain why. Okay. Then the next thing is to introduce our curly brackets. Okay. So we'll have them this way. Then indent your code for the sake of Betty styles. Write your codes here. That is all. So anything you want this program to be doing, say in this our case, we want it to be printing x. So we'll just go ahead and print x here and say, sorry, there shouldn't be a comma here. Oh, my x should be here somewhere. Okay, once I've put this inside, it's going to execute. So let me quickly go to our online compiler so that we can start from there. We have told ourselves we need an initializer. We are dealing with a variable. In C programming, you always have to declare the variable before you use it. So for that matter, we'll go ahead and declare the variable x. Say it is an integer. Then we want to print 1 to 10. So we use our for loop, open the bracket, and the very first thing we type in there is the initialization. So let's initialize this variable. X is equal to 1, followed by a semicolon. Then we go and state the condition. What is the condition? We want to check, is x less than 10, followed by another semicolon. And finally, if it is not less than 10, or if it is less than 10 in this case, what should we do? We should increase the value of x by 1. Okay, Then we go ahead and introduce our curly brackets. Inside the curly brackets, what we intend or what we want is to just print our x value. So x being an integer, you can pass I or D, whichever one you want. Then comma x. Okay. I hope this makes sense. Let me go ahead and run this and see what we have. Wow. Then it means when I was doing the work earlier, I miscalculated something. So there should be an equal to there to get our 10. Okay, good. That's fine. So there should be an equal to there to get our 10. And the structure, as you can see, it's as simple as I explained it. You just need your initializing value. You need the condition. Then you need this. That's how do you increase it, okay? How to increase it. Any questions? Does it make sense? Any questions? Let me know. What's the vibe? Are you getting it? Yes, give me feedback. Are you getting it? How is it going? Should I go over it or I should just continue?
Yeah, it's going.
Yeah. Okay.
Yeah, we're with you.
All right, good. So that is our 4 statement. Let's get another example and use 4 to achieve. Yes, Haruna.
This thing is 4. So why didn't you use if?
You said why didn't I use if?
Yeah.
Now I want to understand why you are also looking for if.
Okay, so the thing is, so you are saying if and x is equal to 1 or x is less than or equal to 10.
Okay.
So that's where I'm coming from. But instead of saying you said 4.
Yes. So what I've said already is that with a loop, I think I did an illustration here. With a loop, there is a condition inside the loop. The if statement that you learned is a condition that you learned, like you learned a conditional statement. So for the if statement, it was just the conditional part, like this part. That's all that it was doing. Then it was giving you output. There wasn't a feedback into the condition again. So the difference is that in the loop, sorry, let me go to the blackboard. When you take care of any loop, inside the loop itself, the loop has a condition, but it also has a feedback back into the condition. That is what makes it a loop. So inside this for loop that you are talking about, there's some sort of an if statement in there. That condition is inbuilt, it's inside. Anytime you use for, there is a conditional statement in it. But you don't have to come and state the if. There are instances where we will need to nest if into another for loop. But the for loop on its own, first of all, checks for a condition, whether it is there or not. So it's using the if inherently. It doesn't state if, but inherently it is using if to check for this condition. All that makes it a loop is the fact that there is a feedback mechanism into the condition again. So in the same way, the while loop tool has a similar thing. It checks for a particular condition. So I told you that there are 3 important things when it comes to a loop. We need a condition. So you don't have to go and state it. The moment you have written is x less than or equal to 10, the first statement is already checking whether this is there. That condition is it met? If not, do something. If it is met, do something else. So it is actually checking, but you don't need to explicitly write it out. I hope that clears the air.
Yeah, I've not gotten it.
Okay, good. All right, so let's see. Okay, we want to print A, B, C, D. Should I go to Replit so that people can practice with it? Or I should keep using this one? What's your suggestion?
Isn't this?
I should use this one. Okay. So the next thing we want to do, this is the first one we did to print.
I have a question.
Yes, what's the question? Come here.
Okay, my question is this: when you after declaring the variable x,
Okay.
then you went to the four, what's that called? Comment. What's that for? The condition.
Loop, for loop.
Yeah, the for loop condition. Why
Mm-hmm.
you declare x plus x lesser and equal to 10 in after the declaration of the x?
Why didn't we declare it after
X, yes, the value of x.
after this?
After
Which of them? Sorry.
No, not
After here.
X. Yes.
So you mean I should have brought the one here? Is that what you are referring to?
Yeah, I want to know why is it not there?
Okay. So in the first place, just to answer that question, we've already mentioned that there's the nature for the loop. Okay, the structure that we've been given is that this is the format the for loop should take. That is the format it should take. So always just keep in mind that that is the format for the for loop. You need to initialize a value inside the for loop. We need to add a condition. Then we need to add the increment or decrement to it. Okay, so those are the three things that we are going to be using. But these ones, even though are needed here, they are optional. They are optional in the sense that if I go ahead and put equal to 1, already I've initialized the value of x. So my loop should still be able to run and give me the value. Do you get it?
Okay.
So it isn't an error to do it that way, but the recommendation is that for the for loop, the nature of the for loop is such that the initial value is assigned here. And I don't want to do it up here and come and do it down here. So I'd rather not declare the value. Sorry, I'll declare the variable but not initialize it here or not assign any value to it here. Then I'll do the assignment inside the for loop structure. But just as you saw, if I take this out, then I can come and say equals to 1 here, and it should still work for me. Note that even though I've taken the first part out, I still have my semicolon here. Please pay attention to that. There is nothing in front here. I haven't written anything here, but I still have to tell my program that there is an information that I know has to be here, but I've already declared it, or I've already given that information out. So I'm not going to declare it here again, or I'm not going to use it here again. That should come. Your semicolon should come. So let's take the semicolon out and run this. And you see we get an error. Do we get it? There is an error here because it is expecting that there should be a first part to the for loop before the condition. And the first part is always initializing a variable. For that matter, we have to bring our semicolon before this program runs. I hope we are clear on that.
Yeah.
Okay, good. So just for the sake of good practices, let's always put our x value here so that we'll get what we want. All right, this our program is doing one thing, is printing out 1 to 10. What if we want to print A to Z? If we want to print A to Z, so let me just comment out all of these.
Can you hold on a little bit? I want to see. Because I try to replicate what you are doing, but there's an error. So just wondering where the error came from. Actually.
What is your error message saying?
Just complain on one of them. Okay. I think the challenge is that I use an X that is greater than I use a capital X.
Oh, okay. Okay. So
okay, yeah. Wow. Wait. It's printing 1 to endlessly.
you mean
Mine is
what is up? Do you have your condition right? Your condition. And if okay, I think that error can be imitated here. If it is printing endlessly,
what happened is
you didn't bring your plus here.
No, it was there. The plus is there. But what I did.
We can't hear you any longer. It's good we learn from mistakes and errors, okay? So that's why we have to delve into some of these things. Because the moment you've never faced it before, the first time you face it, you become frustrated. So I want us to address it. But
sorry, my light just went off, so I have to switch to phone level. What I did was after the plus, there was a semicolon inside the brackets.
Yeah.
Now, yeah, inside the brackets, and then it printed.
If you put a semicolon there, it tells you that there is an error. Expected the semicolon, expected the bracket before this. That's what it tells you. So go and fix it. It wouldn't print the rest.
Wow. So is that it printed from 2?
It printed from 2. As in, it started printing 2.
It started from printing 2, 3, 4, 5, then endless like that.
Doesn't mean you did this. Doesn't mean you did this. Even that
no.
Unless if this is not there.
No, that's not what I did.
Okay. Let's see what happens. Okay. Let me try this too.
But sometimes you have to check for spelling, so those ones do also cause mistakes.
I wish I could get a replica of the error you had, so that we all learn from it.
Like I've just tried for 8 times and it was giving me mistakes, so I checked and there was errors in the spelling. So I corrected them, but now I'm getting correct one. Yeah.
Okay.
You can skip or type one letter twice.
Okay. All right. So let's continue then. Hopefully you understand it. That's what is important. Then also the error messages. You should be able to read the error messages. Let me run this and see what is here. The error message.
It's not giving me error. It just printed 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 continuously like that. Maybe I should come on.
Then it means that we are not getting this condition. Because if it is increasing, then it means if it is increasing, this is working. The initial value, if it started at 2, then it means that something is changing this your x value to 2. So you are getting 2 here. Then this condition isn't there. If this condition isn't there, let's see what happens.
Yeah, this is what I'm getting, but the condition is there. X is lesser and equal to 10.
Are you sure you are not using capital X there?
X is equal to 1. It's
X
not less or
what I have
not less.
4 in brackets. X is equal to 1. Semicolon. X is lesser and equal to 10. Comma. Okay, I have comma there.
All right. So you found your error. So let me see. Let me try replicating this with a comma. With a comma,
it's not common.
it's still not giving me the error that you are getting.
Then I have a semicolon after the x plus plus.
No, take that one away.
Okay.
Okay, so we've been able to replicate your error. So, do you know what it's doing here?
Yeah.
What this error, what it's doing here? Let me explain this for you. What it's doing here is, well, it's initialized at x is equal to 1, but this condition is considering this whole thing as the condition that you are checking for. The condition is x less than or equal to 10. Add 1 to x. That is what it's doing. So as soon as it checks, so for number 1, x is 1, it brings it here. 1 is 1 less than or equal to 10. Then it is, so it goes ahead to add 1 to it. This condition isn't, this actually is overruling this condition. So even if x becomes 12, this condition doesn't mean anything. All that is going to happen is that this is going to take your x value and add another 1 to it. That's how come you get all these. So your condition isn't working because of this. Okay, so we need to actually break it that way, then take away this. That is the ideal way. Note that, just as I explained, we need 3 things. Okay, we need 3 things. So all those 3 things can just be specified this way. In fact, when you do this, you've initialized. You have the right for loop. This thing can be considered as a for loop, even though there are no conditions, there are no initializations, nothing. So far as these things are in there, it serves right. You get it? So anytime you omit anything, like you omit one of these, it's seeing everything here before it as the initializing. Then everything in between it is seen as the condition. Then everything after it will be seen as your incremental or decremental values.
Okay. If I may ask, really, what is the how can we define the comma and the semicolon in this case? What is the work, so that one will know that there's a difference between all of them? It's not, no, I want to see it now, not just about cramming, the format or the prototype, but being able to understand the reason why. Okay, just like you said now that, putting that semicolon at the end, actually overwrites the other one. So how do we know what is the essence of the comma? What does it do to the line there?
Okay.
Which comma on line 11?
So the comma, when we add it, before,
yes, I get your point.
Yeah,
that's in your case where you made a mistake, you added a comma, so you want to understand what the difference is between the comma and so quickly, one thing we should know is that that's why we call it programming language. It is a language, okay, and to every language there is a syntax to the language. I tell you English, like in English, when you ask a question, say, how are you? What's the punctuation you use? Obviously, every one of us knows that you use a question mark to ask a question. You don't use a full stop or a comma to ask a question. All right. So that is the same concept when we come to our programming. when you are using the loop, the for loop, the syntax of the for loop in C programming is you should have something separated by semicolons. That is the syntax. In C programming, the moment you bring a comma, the comma is just separating two things. Okay, so it isn't very, let me see. So for instance, when you are declaring a variable,
Sorry,
you
come
can
again.
declare, I'm trying to explain it. You can declare multiple variables by using this. Okay, so let me go to compiler. Here, we know that ideally, if let's say we want to declare 3 variables, x, y, z, I could do this, y, then z. Okay, this is the syntax that we've been taught. But if I want to put all of them on the same line, then I can just delete these ones and separate these variables with the comma. So all that is happening here is that when integer will be applied to this, integer will be applied to that. So we'll get int x as 1. C programming with compiler will see it as integer x. That's the first part. Then you still take this and apply it to this one. So it has integer y. Then it takes integer z, like that. So basically, the command there is just to separate terms. Just to separate terms. The semicolon is for ending. The way full stop in English is for ending. In programming, we use semicolon to say that I've come to the end of my statement. So your comma in programming language or in C programming is similar to your comma in your normal English. That your comma is showing that there is a break in the statement, but you haven't ended the statement. So there's something that is continuing. So the execution has to continue. It isn't done. But the moment you bring a semicolon, that is the end of the statement. So that statement has ended. So if I decide that in printing this, if I decide to go ahead and do print f, then print another thing. Okay, so say here. Okay, let me just use that. This thing is not going to throw an error because the compiler is going to see this, the first part, as a full statement and implement it. After implementing this, it will go ahead and implement this as well. Let me try it and see. Where is it? Okay, so we have double declarations here. Sorry. Try and run it. So you see what is happening. It prints out n for the first time, then prints here. Because this is one statement, this is another statement. This is one statement, this is another statement. However, if I put the comma here, okay, it's printing. Ideally, I should expect that it would have thrown an error. But it's printing because it isn't considering this as one statement, like one complete statement. So even though I've explained during last session that the compiler reads from top to bottom, then left to right. Okay, so because this is a print statement, it would issue when it gets here, like it has gotten a full statement. So even though you haven't told it to end, that statement is complete and something has to be done. So if let's say I'm going to tell you, let's say Smith, I'm going to say, let's say the statement is, I'm giving you commands because print is a command that I'm giving. I say, unmute yourself and answer the question. The moment I say unmute yourself, you are going to take that action. Okay, even though I have paused and I'm going to later say something. Maybe let me say unmute yourself. Then you unmute yourself. Because there is a comma there, you wait for what I'm going to say next. Then the next thing is leave the meeting. Then you execute that action too. Okay, so that is what is happening. But be mindful, like when you are programming, hardly should you be using commas in here. Like they are not the ideal things to be using. Hardly. The only times that I think comments become a necessity is when you want to make multiple declarations, as I've done up here. Otherwise, you should always go with your semicolon. Then what Betty style is also telling us is that anytime you have a semicolon, it means you have ended a statement. So push the next thing to the next line. All right, except for cases where we have something like this. This is a peculiar case and it understands it as such. So you have to obey it. That is the syntax that we've been given. I don't know if you are clear on it. Yes. Are you clear on that? We can't hear you, Smith. Smith, we can't hear you. Okay. All right, so let's go on. We want the next program we are writing is to print the alphabets. I think yesterday we had something like that. So let's print our alphabets. So print alphabet, that's A to Z. A to Z. Okay. So to print A to Z using the for loop, what do we have to do? Yes, anyone, based on what we did for the first program, anyone should unmute himself and share with us. What do you think we should do? We want to print the alphabet A to Z. What should we do?
We declare a variable.
Okay, so declare
a variable and assign the letter A to it.
So how will you call the variable?
Alphabet.
Okay, so call the variable alphabet. Do you want to assign right now?
No. If we are using the for loop, let's assign inside the for loop.
Okay, so we'll go ahead and bring our for loop. Yes.
Alphabet equals to A.
Alphabet equals to A.
Colon. Alphabet less than or equals to
alphabet
Z.
Less than or equal to Z.
Increment alphabet.
Okay, so let's increase alphabet. I've intentionally made some mistakes here.
Alphabet. There is no okay. There is if you intentionally made a mistake.
I've made mistakes that I want us to spot. So what are the mistakes with the program right now? Let me just go ahead and print it and show you that there are mistakes here. Okay, ideally, even if I go ahead and print it, the compiler will give us the error. So now let's try and figure it out. What are the errors with our program currently? Let me put alphabets here.
Okay,
yes.
so I think so.
Yeah, goodness, we can hear you.
Now I wanted to say the alphabet, the last one was not spelled correctly.
Okay, so there is a problem with this spelling. What else?
The A, I think there should be inside like a inverted comma. The
Thank
A and
you.
Z.
So it should be a character.
Yes.
If there should be a character, what else?
I don't think any of that thing is important again. I don't know. I think
check it well. There's a problem somewhere.
We have declared alphabet as an integer, but we are initializing it to characters.
Thank you. So we've declared the alphabet to be an integer, but the value here is a character. So we'll have to change this to last one. What's the last one? Last error. So we should all open our eyes.
Back again.
The last one is on line 20.
Think we should remove the
line 20. Okay,
back.
Thank you.
Yeah, the format specifier, it should be.
Thank you. So the format specifier should be a C. Thank you. It should be a C. So please, let's open our eyes to these petty things. You may have written a program, you think that everything should work, but not. I wish, let's go back. This today, as part of the lessons we have to learn, I mean not on the PLD, but in the intranet, one of the things we are doing currently is debugging. Okay, so that is what we are trying to do here, being able to figure out exactly what the problem is. Okay, so I'll just copy this snippet of code. Let me open Programmers again. Then paste that snippet here. Then I want to change it back to the errors that we had and try and solve it without the help. Without us. Let's use the compiler. Read the mistakes from the compiler and try and solve it, if any. Let's see if it's going to guide us to do that. I hope those are all the errors we had. So let's run this. Cool. So this is what you should understand, that the program or the compiler reads the program from top to bottom, from left to right. Always keep that in mind. So the very first error that you are meeting is probably on top of every one of them. And sometimes it could be that all the other errors exist because there is a first error. And when you solve the first error, you may end up solving the rest of them. Not in this our case, because I intentionally made more errors. But there are times like that. Okay, so whenever you are debugging, you want to always also start from the top to the bottom. Please pay attention. Don't go and correct something down here before you start looking at something up here. So up here, the first thing it's giving us is A, undeclared, first used in this function. So it is seeing this A that we have here as a variable itself and not a value. It's seeing the A as a variable and not a value. For that matter, it's telling us that this A, this is the first time we are using it, so we've not declared it. So that is what is written here, undeclared. Please, this is the debugging that we are doing. Try and understand. The moment you understand these ones, you are able to always correct your mistakes. You don't need a third person to look at it before you correct it. Even the checker that we use always gives us the errors. So this is online. It's telling you that this program that you are doing, line 18. On line 18, there is A, which is not declared. Okay. So you come here and check line 18. A is not declared. Do I want it as a variable? No. I actually want this as a character. Okay. If that is solved, let's look at the next thing. The next one too is the alphabet Z. So Z is also not declared. So please pay attention here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, because of the spaces in here. But what is happening here is that this is 18, character 21. So line 18 and character 21. Okay, so that is what you count. The empty spaces are also being counted as characters. Okay, so up to 21. Then the next error is found on 1836. 1836, there is an error, that is Z, undeclared. So we don't want it that way. We want to make it into this, a character. If that's the case, you see, those are the only two errors that is solved. It didn't see the errors with the integers because we call it integers. It's expecting an integer, and we haven't passed anything to it yet for it to tell us that, hey, you rather pass something else. I think there is a last one here, which is still on line 18, but character 39. It's telling us that the alphabet, this alphabet spelling is not declared. So it means that there's a problem with it. And he's making a suggestion for us that this is a suggestion. We should face an L here. So let's go face an L there. Now we have solved all these three errors that it gave us. So let's go ahead and run it again. It's giving us answers. Who can tell me why it's giving us answers? Why is giving us answers?
All these are in ASCII.
Thank you very much. So it's giving us the ASCII value for the characters that we have here. Because we are forcing the characters to go into integers. these are characters, but instead of collecting them as characters, you are rather collecting them as integers. For that matter, it's forcing them to give you integer values. If we don't want it that way, then we should change this to char, because that is what we are looking for. All right. So we now have A to Z as we wanted. Are we clear on that?
Yes, yes.
Okay, good. So let me quickly add the...
I'm sorry, please, I have a question.
All right, sure, go ahead.
So if we are to use the int, that means we can use the ASCII value of A and Z, right?
If you pass the ASCII value to it.
No, if we instead of using, sorry.
What you mean right now is instead of A, you do this. And
yes.
No. So if you pass this and it's still integer, it's going to read it as integer. So it will give you 97 back.
Oh, okay.
ASCII is when you are dealing with characters. Okay, so the character has a value, and you can use the value to get the character. For numbers too, you can pass the ASCII values into characters. So that's why we use putchar. Putchar is for characters. So the moment you pass a number to putchar, it's forced to go and bring the character value of that number. But if you pass a number to an integer, it's still an integer. So it wouldn't go and convert it to ASCII for you.
Okay.
All right, sure. So let's, with these two basic examples, I want us to look at while loop. Okay, with these two basic examples, we'll look at while loop, then we'll look at nested loops. I think that's where a lot of us had problems. Okay, so while loops, is it any different from the for loop? Not really. It is not really different, and we've already stated that for every loop, we need three things. We need the initializing value, we need a condition, then we need either the increment or decrement. But the way it is presented, that is, the syntax is different for each of the loops. For while loop, unfortunately for it, we don't initialize inside the loop. So for every while loop, your initialization should be outside the loop. It should come way before the loop comes. Unlike for loop, so when we started with for, we said that you should initialize here before your condition, then your increment or decrement. For the while loop written like this, all the while needs to take is the condition. So you need to put in here the condition, but you should have initialized the value before the loop. Then inside here is where you pass your increments or decrements. Do you get a structure? So it is not any different from the for loop, but this is how we present it. Initialize before you start the loop, then the loop will just take the condition, then you increase or decrease inside the body of the loop itself. All right. And while loop is, in fact, I think sometimes people think these things are abstract, and I always want to advise that stop thinking that these things are abstract. They are things that you do while you are still here. I want you to pay attention. That is a while loop. The moment you leave here, you can decide to do anything you want. So you are out of that condition. In this case, the condition here is whilst you are still here. So I'm going to check, are you still here? So the first, for me to initialize it, I need you to be here. So that would be my initial value. Be present. Okay, so that's the initial value. Now that you are present, the next thing I want to check is my condition. The condition is, are you here? Are you here? So if you are here, then what I'm saying is that you have to pay attention. So keep paying attention, keep paying attention. We are working with time. So let's say you came 1 minute, 2 minutes, 3 minutes. Like the moment you leave, you can do whatever you want. Okay, so that's how practical the while loop is. Almost everything that you do, probably based on a particular condition, while you are still with ALS, you have to do your tasks. And we know that every single day they keep adding tasks. So while you are still with ALS, you have to The moment you leave ALS, stop doing your tasks. I hope you get it. So that is how practical it is. And it helps us, these loops helps us solve a lot of problems. And I keep saying that as a programmer or a software engineer, you are training your problem solving skills. So you realize that yesterday we had a lot of problems. I mean, the tasks that we're given, there are a set of problems that you can face practically. So you need to come up with solutions. The solutions are not always already made. You don't have to think about it. In this case, should I use a while loop or should I use a for loop? And if I'm using a while loop, what will be my condition here? What will be the initializing value? What am I going to increase? Okay, so basically that's what is going to happen. Now let's take, okay, let's use this one. We'll start with the very first one that we did. We printed 1 to 10. So now we want to use while loop to print 1 to 10. We want to do that with while loop. Okay. So just as I said earlier, we need to initialize a value, but already we need to declare a variable. So let's declare x. X is equal to 1. So here we are allowed to do the declaration and initialization because we need our initial value even before we create our loop. I could also have decided to do it this way. Then I'll come down and say, x is equal to 1. But I don't like it when it's this way because they are increasing the number of lines that the compiler has to go through. Always remember, compiler will go from top to bottom. This means that the more lines you create for it, the more work you are giving the compiler. So if something can be put together, just put it together as such. Okay. Then once we have initialized this value, let's go ahead and come up with our loop, the while loop. So that is the structure of the loop. And I keep seeing this mistake a lot of us are making. When you have any block of code that has this curly brackets, Betty style says that you should indent the content. So don't come here and be writing from here. No. Once you have curly brackets, always go inside, one step inside or one tab inside before you write your code. It's the same thing. The main one too is like this. Don't come and be writing your code here, right under the curly brackets. Betty style will flag you. The very first thing you know is for every curly bracket you come across, just make sure that you use your tab to indent the content, okay? All right, now let's go ahead. What are we looking at? Condition. What's our condition? Our condition is that x has to be less than or equal to 10, okay? Then what was the increment or decrement value? We're looking at x plus plus, which by now I guess you should understand what x plus plus means. Another mistake I spotted among some others yesterday is that some people put a colon here, a semicolon here. It is wrong. Ideally, the loop is, this is the structure of the loop. It's like this. That is the structure. So if you want the loop, this is a whole statement on its own. So in some programming languages, when you write your loop like this, after this curly brackets, before you bring your semicolon, but C is being liberal on that one. We are not supposed to bring the semicolon. So this is the structure. Keep it in mind. Don't bring any semicolon here. Not for the while loop, not for the for loop, not for functions. So you see that the main that we have here, we don't bring a semicolon here. No, pay attention to that. So now we actually have the structure running, but we are not outputting anything. So if I go ahead and click it, nothing is on the output because we haven't output anything. But we want to print out the numbers. Okay. So if we go ahead and print it, we'll get 1 to 10. The same result we got with our for loop is what we are getting with our while loop. So almost anything you can do with a for loop, you can also equally do with the while loop. The difference is in the structure. Remember, for while loop, you need to initialize before you write a while. Then the while takes the condition before inside the body. In fact, at the end, mostly, the last thing that you usually declare in a while loop is the increment. Okay, is the increment. All right, now let's try this with printing A to Z. I need someone to join me. Print A to Z. Yes, anyone? We need to print A to Z. Anyone, unmute yourself and help me out. Yes.
Okay, cha alphabet.
All right. Okay. Alphabet is equal to
A to Z.
Is equal to A to Z. How do I write that?
You put it in a bracket. What do they call this thing? A/Z.
Is it slash this way?
No. I don't know the names of this. Yes, and it's a character, so it should be inside the.
This way.
Yes.
Okay. Are we sure about that? Does anyone have a problem with that? Does anyone have a problem with that? Or we are all cool with it? Okay, go on. I think everyone is cool with it.
Okay, so
it's a problem. All right, you goodness, continue. We'll talk about it.
Okay. While A.
Wow.
Open bracket. Open. Open. Less than. Equal to Z.
Equal to Z.
Then you open the curly brackets.
Okay.
Print F.
Print F.
C then /N.
Okay.
Comma. Alphabets. Plus. Okay. Should there be plus? Okay, you close that one, then down you say alphabet plus.
Alphabet plus.
So close the brackets.
All right. Good. So we have this code. When we run it, it's going to throw us a lot of errors anyway. So we are going to debug it. Anyone to help us debug the code? Yes, this is actually the best way to learn. I don't want to run the compiler because it will point us to where the problem is. Okay, so let's try and figure it out ourselves one by one. What do you think? If you spot any of them, it doesn't have to be the first one. If you spot any of them that you think, no, this thing, I think we should change this one. This should be changed. Yes. Let's see how we do that. Guys, please, there's no time. We have a lot to cover. We've not even started talking about functions. Kindly come up with your answers, then we can move fast. Yes.
It's looking good to me. I can't really figure out any.
Okay. Smith is saying that it looks good to him. He can't really spot a problem. Ooh, any other person? So I can see that there are problems with it. Yeah, so open your eyes well. Goodness and Smith, open your eyes well and let's see. You'll be able to see. There are problems with it.
I think we need to reinitialize that variable.
Hey, your name here is Fitness Freak. I can hardly hear what you said, or I could hardly hear what you said. So
On line
come
17.
again.
On line 17.
Line 17, okay.
Yeah, we should say car alphabet is equals to A in single quotes.
Okay. So I want to put yours, what you're seeing down here. That's what you said?
Yes.
Okay. Yeah. What else?
I think that's it.
Okay. Orion, do you want to say something? In fact,
Yeah,
I think
I
I should
think
start calling names.
since
Yes.
since,
Mm-hmm.
since okay, I want to talk about the increment, but he's
Okay.
correct. He's
Honestly,
incrementing it below, so I don't think that's the problem.
Oh, okay. All right. So he wanted to talk about the increments, but he has realized that we are increasing it at the bottom, so it's not a problem. Yes. Oh, there should be a number of problems here. Okay, so for now, this has been dealt with. The problem here is you can't say that this is equal to A to Z. Victor, do you want to say something?
Um, okay,
yes.
it's going to yield at line 20 also because the variable
That's
z
line
is not defined.
20. It's a different.
Okay. All right, thank you. Line 20 also has a
Yes.
problem.
Yeah.
Okay. If we go ahead and even make this, the previous one that we ran with a for loop, we realize that if you leave this as A, it's going to see it as a variable. If you want it as a character, you have to introduce that. Okay?
Oh, okay. Sure.
Yes. But the other problem is that if this is what you are checking, if this is your condition, A is less than or equal to Z. Do you know what is going to happen when you run this code? This code will print will print the value that you put here, alphabet, forever. If it is on your own computer, it can freeze your computer. Should we try it? I don't know if it's going to affect the browser anyway, but should we try it? Maybe we should so that everyone will see, and I'll explain why. Okay. It's unfortunate. I don't know exactly what is printing right now here, but as you can
It's
see,
printing every character, ASCII character.
as ASCII
ASCII
characters.
character.
But what I want you to see is the repetition. Okay,
Yeah.
so it repeats after a certain while. It repeats after a certain while. So this is going to repeat. Like it will keep repeating like that. It's not going to stop until you decide to stop it. And when you are running while loops on your laptops, be careful. If you end up into this problem, your computer may freeze. Okay, it happens a lot of times when we are learning while loop. The reason is that this condition is always going to be true. Always. That is what you have said, that A is less than or equal to Z. Always. A is always less than or equal to Z. You are not changing the value here. You haven't done anything to change the value here, inside here. All that you are changing is alphabet. So alphabet keeps increasing. So the first thing that it comes here into the while loop checks is A less than Z. We all know that A is less than Z. So it goes ahead to print A here. Then it comes again because you've increased. Now alphabet is B. Let me illustrate this on the board. Okay, so what we have is we have declared alphabet. Okay, sorry. We have declared alphabet to be equal to A. And our while loop is checking for the condition that A is less than or equal to Z. Then in here, we print, let me just shorthand it. So we print our alphabets, okay? Then we increase alphabets. That's all we are doing. Then we increase alphabets. Then we end. So we did plus here. What is happening is, for the first time, this alphabet is A. So it comes in, what it checks for is A less than Z. Yes, A is less than Z. So go ahead and print alphabet. That's A. Then add 1 to alphabet. So we now get B. Meaning now this value here is no longer A. It has changed to B because we have added to B. Okay. Or wherever we see alphabet now, the value of alphabet is B. So it comes in here to check, is A less than Z? You know what? Because you haven't changed this, it's still going to check, is A less than Z? Yes, it'll give you B. Go through the same process, get C. Come, is A less than Z? C. Go to the, so it's going to keep printing all the characters that there are. After it is done printing, the whole cycle is going to begin again, like that. Okay, so I said that if you are doing it on your computer, you may end up crashing your computer, especially if it's something that is not ending. So this is called some sort of an unending loop. Okay, this loop is unending. Unending loop. That is, if you want to do something forever, all that you have done here, if we should simplify it, is this. You are saying, while true, do something. So if you see something like this somewhere, that is what it means. Always it is true until the condition defaults, like something happens to the condition and it changes. But over here, we are not changing this condition. So it's going to always be true. How do you correct it? Yes, quickly. How do you correct that? Yes.
I think we should use the ASCII values for the alphabet.
Not really. That's not the solution to this problem in particular. The problem here is with our condition that we are checking. This particular condition will always be true. We want a condition that can change with time, that can become false with time. Look at it carefully.
End loop.
Come again?
End loop.
End loop. What do you mean by that?
Okay, so after the I don't know.
Okay. All right, so you let me go ahead and mention it. Simply, this thing shouldn't be A, it should be alphabet. Because what you are increasing here is alphabet. You are increasing alphabet. Okay, so that value is changing. But what you wrote here, even though in the first instance it was representing A, you decide to hard code A here. And that will always remain A. A is always A. So if you don't want it that way, you want something that is changing, then what you are already changing in here should be alphabet. So let's go ahead and run this. And we get A to Z. The reason this is possible is because now, after each run, alphabet is increased. So when it comes back to the loop, it comes with a new value to come and check. It comes with a new value to come and check. Please, is it clear? Do we get that? Yes? Oh, you people should be responding now.
Yes.
Okay, thank you. So let's go back to our error. For the sake of the debugging lesson, let's go back to our the first problem that we had initially. This was A. Let's see if our program will be, I don't think it will be able to pick it up for us because you will see it as running. Then we had this one. Okay, so let's run this and see. That is what it gave us. Why? Anyway, I don't really know why it gave us that, how it interprets this, but all you can see here is that you're not getting what you are looking for. So there is definitely a problem somewhere that you need to resolve. Okay. Okay. All right. So let's correct this as we did earlier. Good. Now run it and see. Great. So we have our while loop printing A to Z and our for loop also printing A to Z. I hope we get that. Now, let's do some more complex examples. The first example we want to do is we want to print from 1 to 20. Please, am I allowed to delete all these things? Because the last time we said we should be keeping track of them. But unfortunately, how to keep track of them right now? Programmers. Okay. So the next one that we want to do is we want to write a program to print out all even numbers between 1 and 20. Okay. See, these things are simple. They are basic things. But you'll be surprised how many times you would need some logic like this inside a bigger project that you are doing. You'll be surprised that these simple things like what we were doing yesterday, how to make two numbers combine, how to put three letters together, like all those things. You may be surprised. They are just smaller bits of data you are working with. But eventually, when you start building bigger projects, the bigger project is just a chunk of like little ones that have been put together. And as a programmer, yours is to break the bigger problem into smaller chunks. Then we tackle them one after the other. So the first thing you want to do is to check if this is that. Then you check that one. Check if this is this. Then you check that one. Check this. So you solve that small part, you move on to the next small part, you solve it, move on to the next small. That's how you build a big program. Okay, so don't see these things as something that is irrelevant. They are very relevant, and in fact, you may be needing them in your programs. I bet you. Okay, so let's try and figure this out. How do we go about it? Any ideas? Anyone to throw in an idea? In fact, I keep saying that when you are given a problem, you should come up with an algorithm to solve it. So what's the algorithm? How do we solve this problem? What do you think? We need to print even numbers between 1 to 20. So you yourself, anyone here, I'm asking you, give me all the even numbers between 1 and 20. Yes, anyone. Give me the even numbers between 1 and 20.
2, 4, 6, 8, 10, 12, 14,
2,
16,
4, 6, 8, 10, 12, 14, 16, 18. Okay, how did we get it? Sorry, I've even pressed. How did we get it? How do I know that 2? How do I know that 2 is an even number? How do I know? Or in the first place, you have to ask yourself, what is an even number? Yes.
I think numbers which can be divided by 2.
Okay, good. So the first thing you need to know is that before we can solve this problem, we need to understand what even numbers are. And we have said that even numbers should be divisible by what? 2. Divisible by 2. Okay, so all that we are looking for right now is between 1 to 20. We need to find the numbers that are divisible by 2. Hey, we are getting feedback from someone. Okay. Who is playing the music at this background?
Sajay.
Please mute yourselves if you are not talking, especially. Like when those small noise, it distracts me a lot, I beg. Okay, so let's get this done. If we have been given the range. It means that in the first place, we need our program to print every number from 1 to 20. Okay, we need it to print every number from 1 to 20. Can we do that? Can we do that with what we have learned so far? Can we print 1 to 20? So that will be the first goal.
Yes.
Okay, we are going to print from 1 to 20. Then inside the loop that we are going to use to print from 1 to 20, we are going to bring a conditional statement. So this is where nesting is coming in. But this time around, we are nesting a conditional statement within the loop. Okay, it could also be a loop that we are checking, but let's see how we solve this problem. So we are going to print all the values from 1 to 20. But before we print them, for each of them, we are going to check if it is divisible. Is the number divisible by 2? If yes, print it. So you started with the goal of trying to get all the numbers between 1 to 20. But before you issue your print command, you check if that particular number you are about to print is divisible by 2. And if it is, you go ahead and print it. So how then do we know that a number is divisible by 2 or not? How will you know that? Yes, in programming, that's we have actually done this, so I expect that you should know. How do you know that a number is divisible by 2 in programming? In fact, not even in programming. In normal life, how do you know that a number is divisible by 2? Or what does it mean if you say a number?
2, you get 0. The remainder
you get
is 0.
When there's no remainder
Thank
value.
you. Okay, good.
After
So
divide.
what arithmetic operator do we use to get remainders in programming or in mathematics? What arithmetic? Percentage. Please don't call it percentage for the purpose of what you are using it for. Thank you. So the modulo sign. Okay, so we'll find the modulo of the number, and that gives us the remainder. So it means that here the condition we are actually checking for is the number. Let's assume the number we are dealing with is x. That number modulo 2 should give us 0. Should give us 0. But don't forget that in programming, a single equal to sign is not equal to, right? A single equal to sign is rather assignment. So we need a double equal to sign to check these two. So that is what we are going to be doing. Before we go ahead and print, our goal is to use a loop to print 1 to 20. But before we execute the print, we are going to check this condition. Check if x modulo 2 is equal to 0. If it is, then go ahead and print x. If not, don't print it. Okay, so how do we achieve that? By writing code for it. Yes, suggestions quickly. We want to print in the first place. Let's focus on just printing the 1 to 20. Let's do that. Print 1 to 20. Somebody should help me print 1 to 20. Yes. Yes. Oh, who is coming? Help me print 1 to 20. Smith, I think you have a problem with your microphone. Kindly check it. We can't hear you.
Hello?
Hi. Hello?
Hi.
Okay, so, yeah. Can you hear me?
Yes, goodness, I can hear you.
Okay, so int x,
int x
column, then for x.
Okay, for x.
Number equal to, no, or int number.
Okay, you want to call it number.
Yes,
okay.
Int number.
Okay.
Column. Can I use 4?
You can. Any of them that you want to use, you're allowed. In fact, we are going to implement it with both. So choose the one you want. Yeah.
Okay, 4. For open brackets.
Okay.
Number equal to x.
Number equal to x.
Then column x less than equal to 20.
Less than equal to 20.
Then column, then x increment.
Okay. Okay. Should I go ahead? What am I printing?
I'm supposed to use 1. I'm supposed to use 1.
1
x
way.
equal to 1. So instead of int x equals to 1, correct?
I want you to finish before I comment on
it. Yes, before we look at it. So let her finish. Let her finish.
Okay. Int 1.
Okay. Int what? 1.
Then
so I should do it
then column.
Int 1.
Then yes, integer 1.
Okay.
Then column.
Okay.
No. Sorry. Int x column.
Int x.
Please. Int x column for x equal to 1.
For x equal to 1.
1. Then x less than equal to 20. Then x
less than
plus
equal to
plus.
20. Okay. So why did you declare int number?
I was being confused if I was cracking something in my head. It wasn't correct.
Okay. Then what do you print?
Okay, print. We're just printing 1 to 0, 1 to 20, right?
20. Yes, please.
Okay, print curly brackets, print f, open brackets, modulus I / n.
So when you get here, I'll prefer you use percentage I. Okay, so it's not representing modulo here.
Okay, percentage I.
Okay.
/ n. They are in column in.
Okay, so I hope that's it.
Comma x, then close brackets and column. Okay,
sure. All right, so let's run this and see. We have 1 to 20 printed out. So you've done well. Thank you very much. She was confused initially. But anyway, in this case, you could have used a number. You started with a number, but I think X was in your head. It was trying to force its way out. It wanted to come some. So that was what was giving you the problem. But we could have represented this X with anything at all, except that if you use number as your variable, it should run throughout. This would have been number is equal to 1, number is less than or equal to 20, number plus plus, okay? But since you decided to go with S, let's stick with X. All right, so this is a program that we have. It's currently printing 1 to 20. That is how you solve the problem, okay? So anytime you're given any set of problem, this is what you have to think through about. And I think when we get to the work that we were doing yesterday, you will see some of these things. We actually haven't finished solving the problem, but we have gone one step ahead. We have gone one step into it. We've solved the issue of having the numbers printed out. So now we know how to print the numbers, but we want to make sure that we don't just print any value of X, only the values of X that are even numbers. And we've already established on our board that for a number to be even, we have to check if the modulo of that number is 0. So what do we do? How do we check that? Yes, anyone? How do we check if the modulo is 0? Yes. Oh, some people are here. Probably today is your first time here, but you are not speaking. And we need to hear from you all, okay? We want to help ourselves. So if you come and you're just listening and not contributing, I think it's not the best. All right.
Okay, so I have a
Please.
suggestion.
Okay. Yeah, go ahead.
Okay, so while x modulus while x modulus 2 equal to 0,
modulo 2. Is that it?
okay, or if, can we put if statement in for?
Yes, please, you can.
Okay, if
So,
x modulus 2.
okay. Thank you very much for your submission. I'm very grateful. The rest, kindly emulate what Goodness is doing. Share your thoughts so that we can walk them through. All right. Just to make a point here for us to take note of the difference between the loop and the conditional statement. Okay. So even though the loops check for conditions, you should know that you only use a loop when you want something to be repeatedly done. When you want something to be repeatedly done, that's when you use a loop. Here, your interest is checking if something is an even number. That's all you're interested in. You are not concerned about continuously doing something. So for the first one, we use a loop because we wanted to print out all the numbers. We wanted to continuously print out numbers between a certain range. But for the even number, we are now interested in, we already are printing the numbers, but before we print the number, we want to check if it is even or not. For that matter, we are not going to use a loop. We are rather going to use a conditional statement. So in this case, if will be the most appropriate condition to use. So we'll go with if, then as you said earlier, x modulo 2 is equal to, is it right? What I've written, right?
There's no space after the equal to 0.
It's not right.
Okay. Come again.
You should use double. You should use
Okay,
two
so I
equal.
should use double equal to. Thank you. So that is very important. Then, who can tell me if I go ahead and run this program right now, what outcome am I going to get if I should go ahead and run it right now? Yes. What do you think I'm going to get? Yes. Smith, still we can't hear you.
I think the same result.
There is nothing inside the curly bracket.
Relax. Goodness, thank you. Oh, let me listen to Donut. Goodness, thank you very much. I'm coming. Let me listen to Donut. I want the others to also contribute, please. Yes, Donut.
Yeah, I think it's the same result because there's nothing in the if, so I don't see anything changing. There's no statement.
Okay, so the same result. Thank you. Great. So we are going to get the same result. The reason is that, as we all know, I keep saying this thing, the compiler reads the code from top to bottom. So it's going to start. Here, we've initialized the variable. Then it comes to the for loop. That's where we begin. Okay, x is equal to 1. Sorry, here I meant declare the variable. We've initialized x here. It's checking. Is x less than 20? Yes, it's less than 20. So please let me explain something here. I think you have to understand how the for works in this way. When we've written this for, then we have x is equal to 1. We have our condition x less than or equal to 20. Then we have x plus. How this operation works is this. Let's say print of %i comma x. Okay. So how this thing works is that when the compiler is reading this code, this is what it does. First of all, it reads this one. Then there is an assignment here, so it's going to assign 1 to x, meaning anywhere I see x, I should replace it with 1. So when it gets here, it checks. This is 1. So it checks. Is 1 less than or equal to 20? It is. Once it is, it jumps here. It doesn't move on to the next one. Smith, are you there? The mistake Smith did was that he didn't enclose the semicolon. He used a comma. So instead of this program jumping into the body to go and interpret what is in the body or execute what is in the body, the code felt that it is not done reading this because there is no semicolon. So he went ahead to do the plus and added the value to them. But the ideal thing is that when it gets here, there is a semicolon. So this is considered as one full statement. Sorry, this is considered the x under less than or equal to 20 is considered one full statement. If it executes to true, it jumps back into the block of the code, then comes to execute this one. So we will now go to your screen and print the value of x. Then after it is done executing this, it now moves to the last statement, which is the increment or decrement value here. Then it finds that, okay, s has been increased. Now s is 2. So come back to the condition. So from here, it comes back here. Did we see that? Let me repeat this again. The for statement, how it works, or how the compiler reads the for statement. Less than or equal to 20, then x plus plus. Then there is a condition in here. Sorry, there is a statement in here says it should print something. Okay. So the first thing is that when you read this one first and initialize the variable, says that, okay, anywhere I see x, the value is actually 1. So when it gets here, that's the next thing. It moves here. Then it says, okay, 1. Is 1 less than or equal to 20? That is true. It is less than or equal to 20. Then come inside the block of code. Come inside the block of code and execute what is here. Once you are done, go to this is the next statement. So let me number them. This is 1. This is 2. This is 3, 4. After incrementing it, come back here. Okay, come back here and check again. If it is true, repeat the cycle. So this is what makes the for a loop. It keeps repeating like this until there is a break out of this. If there is a point in time, let's say x now becomes 21. Once x becomes 21, when it comes here and comes to check, 21 is less than or equal to 20. That is false. So you break out of this loop. Then the C program will continue whatever you wrote here. So maybe return 0, and it will return 0, and your program has ended. This is how the for loop works. Okay, there is step 1 here, initializing a value. Step 2 is moving to this part to check the condition. If the condition is met, step 3 is coming to the body of the code. And in fact, don't forget that this body of the code could have several lines of codes, and they could also have multiple for loops and while loops. They could have multiple loops inside them. So it will go and execute all of them. And imagine if that loop also has a loop within. It will loop until everything is done before it will now come back to step 4 and come and check if the condition increase it or decrease it. Then finally take the new value into the condition to check if it is met or not. Then the same cycle continues. Because of the cycle, that is why we say you are in a loop. Okay, that is why it is a loop. Now let's go back. So we are talking about our statement, how it is reading it. So it is reading it this way: x is equal to 1. So it comes to the next step. 1 is less than or equal to 20. That is true. So it moves down here. The first thing it checks is if x modulo 2 is equal to 0 and 1 is not. But anyway, there is nothing for this code to execute. So nothing happens. It keeps moving on. Then print. So it will print this value. So if we go ahead and run it, we are getting the same result. If we want it to print only the even numbers, then we have to move this into the block that we checked for. So here inside the if statement, we are checking if the value is an even number before we print it. For that matter, if we go ahead and print this now, it's going to only print the even numbers for us. Is that clear?
Yes.
Or any questions? Okay. Any questions for me? If not, I want someone to implement the same code using a while loop. Implement the same code, the same program. Let's implement it using a while loop. Programming. Yes, the same code that we have here. Let's implement it using a while loop. So I usually like to comment these things. Say checking if number is an even number. Okay. Yes, anyone? You guys, there are a lot of you on the call. I can see quite a number of people on the call. Or there are some of you who are shy. Please, so this is our own classroom, and this is how we get to know each other and get better at what we are learning. So feel free to share what you know, because obviously there are people who understand this, there are people who know, but you are refusing to share. Kindly share. Open up. Are you here? Share. Boaben, you are joining us, I think, today. Okay. Yes. Orion, Uncle M. Last time you were here. You are here to speak today. Nice. Oh.
Sorry, I'm tied up right now. That's why.
Oh, okay. All right. Okay. So let's go on. We need to implement this in the, how do you call it, using the while loop. So in the first instance, let's use while loop to print 1 to 20. Okay, that's the first thing you should try doing. Print 1 to 20. Wow, how do we print it? I mentioned that for the while loop, you should always initialize your variable outside of the loop. So I'll start and initialize the variable here before I come to write my while loop and check for the condition that I'm looking for, say 20. Then inside here, the last thing would be for me to apply the increment, because that's what we are looking for. Okay, so if I go ahead and print f %i, comma x. Okay, so we have gotten our 1 to 20. Now we want to check if the number is an even number before we print it. Someone should help me do that. Apart from goodness, someone should help me do that. If no one does, then we are not continuing.
To do what? To do what?
To print the even numbers. Now we have all the numbers printing, but I want to restrict it to only even numbers.
So on line 12, you press enter.
Okay. Let's do it here.
Okay, so you say if then parenthesis,
okay,
x modulo 2,
x modulo 2,
2 equal signs,
okay,
equals to 0,
0,
then open brace.
okay.
Yeah, I think you put that statement on 16 inside.
All right, thank you very much. So this is how we achieve the same outcome with a while loop. Great. Any questions up to this point?
Hello.
Hi, big man.
I wanted to talk, but my microphone was telling me, but it's correct.
Oh, okay.
What the guy has said is, oh yeah.
Okay, all right, thank you. Great. So now, at least for the basic implementation of the while and the for loop, we all get how to do that. I hope that's clear. I need an example of a nested loop for us to work in. Let's see. Oh, no example is coming to my head right now. Let me see. ALX. Which one was?
Task 2.
Task 2 says that we should write a function that prints the alphabet in lowercase followed by. Oh, that prints alphabet in lowercase followed by a new line. That shouldn't be.
Number 2, not 1.
Oh, okay, number 2. Okay, so we should print 10 times the alphabet in lowercase. I think I'd want to make something simple. Okay, do you know what we'll do to simplify it for us to get? Now I think that task we even did it in a previous task where we have the, let's say we have the alphabets multiplying each other. So what I'm talking about here is we need something like this. Combination of the AA, AB, AC, AD up to AZ. Then you get the task I've given. I think we've done it before. Then you come to BC, BD, BE up to BZ, something like that. Where it's like the first. So this concept, let me try and explain this concept. The first thing is that you are printing from A to Z. Okay, you are printing from A to Z, but for each of them too, you are going to also print each of them multiplied by the whole alphabet. Right? Am I making sense? Or you don't get what I'm saying?
Question required.
Come again?
That's not what the question required. It said
no. I'm not talking about this specific question. Oh, I'm saying that yes, because of the way we are transitioning, I want to make it easier to understand. So for now, our focus is printing the, how do they call this thing? Like combination of the alphabets. Okay, that's what we want to achieve. How do we print out a combination of the alphabets in this way? Oh, well, you guys are not understanding it. I think there was something like that in last week's task.
There was something like that in last task.
Yes, last week's task that we can easily do with this. Let me see if I can pick that task. Is it even there? Okay, let's just go ahead. We want to print a combination of the alphabets. Okay, so print combination of the alphabets. All right. So at the end of the day, we need something like AA from AA, AB, AC up to ZZ. We need something like this printed. So if we have such a question, the first thing you want to be interested is in printing A to Z, printing A to Z. Then within each of them, you go ahead and print another loop. Okay, so now let's try this. How do we print A to Z? Let's assume we want to use a for loop for now. For loop. The first thing, let's declare a variable called alphabet, since we decided to call the earlier ones alphabet. Then we have our for loop where we have the initializing value. So alphabet will be initialized to A. Then we are going to check if alphabet is less than or equal to Z. Then we are going to increase it. I think when we are done with this, we should do some form of decrement too, because we've been using the increase. We haven't done the decrement. Okay, so once we have this, if I go ahead and print, hey, did I declare an int? Okay, if I go ahead and print this, I see, hey, sorry, see, okay, let me just pass a space and not a line. Okay, then down here I'll pass a new line. All right, so I hope everything is right, and let's run it. Woo! What's happening?
On line 12.
Line 12.
Your line 12. iPhone.
Okay. Thank you. All right, so now we have A, B, C, D up to Z. Okay, but this time I will want to duplicate it. We want to duplicate it. So what do we do? In order to duplicate this, what do we do? Yes, anyone? Oh, anyone?
You run
Multiply
another
by
for
Z.
Come again. I want each of them. So right now, if I take A, I run another for loop. Okay. So I'm going to run another for loop. But how do we run the for loop? Where do I put that for loop? So what I'm interested in doing right now, okay, is like something like this sort. This your A.
I think the for loop should be where this printf is. This printf alphabet should be
so
there.
we should
So
have.
we are going to declare another alphabet again.
Okay.
Well,
should it come?
We should give it another like we should give it another variable name.
Okay, thank you. So we have to have another variable. Let's call this alphabet 2. Okay, alphabet 2. Then when we come in here, what are we doing here? You said we should bring another 4, but this time we are dealing with alphabet 2, right? Alphabet 2 is equal to B. Okay, so I think that's how the question that we were given the last time, that's how it was put. And the next thing will be alphabet 2 is less than or equal to Z. Then we'll increment it or increase.
Yes. God, where's my network?
We can't hear you.
Is it my own network? No, it's
okay. Not yours. I think it's from Obed.
I got confused though. His network have started singing. Back, no need for it to do.
Linus, are you listening?
Mr. Smith, are you saying something?
Yeah, I'm talking to you. I don't want to. I actually don't want to draw us back. I'm having issue that while loop. I think the only difference between the.
I can't hear what you're saying.
Can you hear me now?
Yes.
Can you hear me now? I'm talking about the while loop.
Yes.
All right. The while loop, I think what makes the difference is bringing the whatever plus plus, the variable plus plus down, right? If I'm not mistaken.
Yeah, what makes the difference is that we are initializing outside the loop. The condition is inside the while loop, while the increment is under the while loop. But inside our actions, like when we say, let's say we are printing from 1 to 10 using the while loop,
Yeah.
we declare and initialize outside. Let's say let me use I, integer I is equals to 1,
Mm-hmm.
is equals to 1. Then under it, we now use the while loop, while inside the bracket I is less than or equals to 10. Then we open a brace for the function, like where
You're going to print.
what is going to happen, where the loop is going to take place. Then we'll print the number, then under it the increment.
Okay. All right. I've been having
Yes.
challenges about trying. Thank you.
Okay. You're welcome. He's back.
I was even just typing. Sorry, my light went out.
Sorry about that.
Let me not complain. It's okay. My light went out. I bought data to try and connect using hotspot. Unfortunately, the network was so bad that I couldn't connect. But now the light is in. Okay, let's try and quickly finish that off. So this was alphabet 2 plus plus. Then, so what do we print? Yes, what do we print? Someone was helping me.
I think we are printing for the first. Okay, we are printing for this second one inside. We are printing for alphabet 2.
So how do we go ahead to print that?
I'm confused now. What are we doing?
We want them to appear like A, B, A, C, A, D, A. So how do you print that?
Yeah. Pucha. Let's use pucha.
Okay, you want to use pucha, that's fine.
Inside it, alphabet.
Inside pucha, we have alphabet. Is it alphabet or alphabet? Which one do you want to print?
Alphabet 2.
Alphabet 2. Is that all?
Yes. Then outside the loop for the other one, we are printing alphabet 1. I don't know. I'm confused though. Confusing me, sir.
Okay. So see, don't worry so much about these things when you can't really figure it out. All right. As a programmer, like you should be testing these things. The idea comes into your mind, you test it to see if it is the right thing. If it is not, you figure something out. So let's go ahead and run this and you see the outcome you are producing. See what you are producing. BC here. There is no A in here. The
Yes.
A is the ending here. That's the very first one. So you know what happened? We went ahead to print all the alphabet 2. So this loop ran, printed all the alphabet 2, then it broke outside to come and print the alphabet. That was A. So the next loop that ran it printed all the alphabet 2, then came to print the last, which is the alphabet. The same thing. So this tells you that if you want them to be printed together, then this your printing of the alphabet shouldn't be outside here, but rather should be somewhere inside. Do we get the idea? So the results, the outcome that you get should inform you whether you are doing the right thing or not. If you realize that you've printed all the alphabet 2 here before coming out to print just 1 for the alphabet 1 or the alphabet, this means that you are doing something wrong about it. So now let's put it inside here and see if we get anything close to what we are looking for. So you run this and you see it starts by printing just A, then it goes on to print BA, CA, DA, EA, FA, GA, like that, up to, where is it? Up to, YA. So there was no ZA. Then it starts B. Then it comes to BB, CB. That's exactly not what we are looking for as well. So what could be the problem here? What could be the problem? Yes. Oh, guys, are you not here?
I think let's use Pucha on line 15.
We should use Pucha on line 15. Okay, somebody says we should use Pucha here in order not to confuse anyone. Okay, so let's use Pucha. Are you sure you're not going to get the same result?
First, hold on.
So what do we get here? AB, AC, AD, AE, AF. Is that what we are looking for? Or if people don't know what we are looking for. So that's what we are looking for, but it's not cleaned up. So we need to clean it up, maybe with some form of spacing. Okay. So how do we add the space? How do we add the space?
I think under this
put single quotes with a space.
I should use Pucha,
then white space.
White space. Okay, let's run that and see. Great. So you have achieved this. Okay. So this is pretty much what you are expected to do in this case. And it's not any different from how do you call it? Printing, what was the other assignment or something? Printing it 10 times or something. Okay. So in that instance, what you are going to be doing is you are going to check for if, like, you set a counter or an integer or however you call that integer, then you check. Once it is less than 10, go ahead and do this. Once it's less than 10, go ahead and do it. Okay, so that can be done. Yesterday, I think there was another practical example that used the same concept as we have used here. It was about printing the multiplication table, 9 times table or something. Do you remember that? Yes.
Yeah, I saw it.
Okay. So now your assignment here is this one. We use the for loop. Try and do it with a while loop. Okay. Then let's try the. I should have tackled the time. I should have tackled the, how do you call it? Functions. We need to talk a little bit about functions. So I'll quickly summarize this while loop. In fact, even do while loop. We've not spoken about do while loop. What do I do? Okay. Did anyone have challenges doing that 9 times table? Let me know. Did anyone of you? Okay. Okay, good. But with this knowledge, do you think you can do it? Because essentially, what we have done here essentially is something of this nature, which you can apply when you are doing that 9 times table. It's something of this nature. So you have, let's say, we have A, B, C, something of this sort. So you can replicate it with the I think I got it. So for instance, with the 1 to 9, you can do something like this. I think we used to do these things in. Then here you have 0, 1, 2, 3, 4, up to the 9. Okay. Then so you do 0 times 0 is 0. 0 times 0, 0 times this 0, 0, 0, 0, 0, 0, then 1, 1. So that's essentially what you are doing. You have one loop multiplying the other loop. Okay. So can we simply do that? Or I should leave that as an assignment and talk about. I think I created a replet for it. Let me just quickly. I created a replet for it. So let me just quickly assess that. Then we can talk slightly about the do while loop. Then talk slightly about functions. Then we'll look at them sometime later when we meet. Okay. All right. So let's pay attention here. I think there were extra conditions that were given. Okay, with how we are going to separate them and things. But if you take that out, essentially what we are doing here is first, you are using a for loop to check if x is less than 0, then assign x to 0, then check if x is less than 10, increment it or increase it. Then you pass another for loop here. Okay, and within this for loop, that is where you are going to be doing the printings. Except that we're given some conditions to check. That's why we have these extra lines to check where to add space, where to add a comma, and the likes. But if it wasn't for those comma and spaces, we wouldn't have these if conditions in here. So the if conditions are in here to help us bring in the spaces and the commas. Otherwise, all you needed is one for loop within another for loop. So exactly as we did this one, you just have one for loop within another for loop. You know that you could have decided, if it was mathematics, okay, if it was mathematics, we could have decided that we are going to print f alphabet times alphabet 2 instead of alphabet then print alphabet again. We could have done alphabet times alphabet 2, and that will give us the product, just as we would do for the multiplication table. Okay, so I hope that gives you an idea how to solve it. Then we can also print this a number of times. So we want to have these duplicates a number of times. You can still bring in another condition to check if it is still less than. So assuming for each of them, for each of these up to where we have the z, where is that? Okay, so up to A to Z. So for each of these, I want to have it printed like 10 times for each of these. Then I have to, inside this for loop, I have to bring another for loop, checking if, let's say, another variable that I call, say x is equal to 1. I want to check if x is less than or equal to 10. Then increase x, then go ahead and print these things, right? Put these ones inside here. Time is against us, that's why I'm trying to hurry up with this. So we declare an integer x, then run this. So you see, now we have creating this AB, we are creating it how many times? 10 times. Before we go to AC, 10 times. Before we go to AD, 10 times. AE, 10 times. If you want to, like, you could have further, how do you call it? You could have further loops inside all these loops. It doesn't seem too practical because you can't right now imagine while you have like be printing this sort of things, okay? But when you are building a bigger project, it could be that there are a lot of conditions that needs to be met. So you have to check for the first condition. If that is met, there is possibly another condition. If that is met, there is another condition that needs to be checked. And this is how you are going to, so that's the concept of nested loops and how you are going to implement them. All right, quickly, let me touch on the do-while loop shortly. So with there are two categories of loop, okay? We have the entry and the exit, something like that. I forgot exactly how they call it, but one is the entry form and the exit form. And what it means here is that let me use the do while loop to explain something. With our while loop, we first of all check if the condition is met, okay? So let's assume that we initialize x is equal to 10, and we come here to check if x is less than 9. Print, let's say hi. Will this be printed? Will it be printed?
No.
No, it's not going to be printed because we didn't meet the condition, okay? But there are times that you want something to be printed at all costs before you start checking in the condition, okay? So maybe I want to print hi. I want to print it before I even check for the condition to see if we meet the condition. Let me get a practical example. What would be a practical example here? Okay, so let's say anybody, I'm just trying to use a real life situation, but I'm not getting a very practical one. So I'm going to give an arbitrary example. Let's say we are you as a human being. I've asked you to be at the gate to a store, and anyone at all that comes in, the first thing you need to do is to greet them. Okay, so your duty there is greetings, all that you've been tasked to do. So I've tasked you to be greeting people, but the greetings, you can do it repeatedly, or you are supposed to do the greetings repeatedly, except that I want you to repeat the greeting if the person is actually coming to buy from our store. So the first thing is, the very first time the person comes and you see the person, greet them. Then now ask them if they are buying something from the store. If they are not buying something from the store, don't greet them again. But if they are buying something from the store, greet them again. Keep greeting them until they leave the store. So even though this isn't a feasible example, that is how the concept of the do-while loop is. So the first thing the loop checks for is, it just goes on to execute. So the do-while loop is written in this way. It starts with a do. So the do, then it goes ahead to do something before the while statement. Do you get it? So all we are going to do is, let's say we say hi to the client. So the do will be this way. Then it says say hi. So hi or something, print hi. Okay, then this will be closed. We'll now have the while to check. Are you buying from us? Are you buying? So now, if the person says they are buying, there is a loop. So go back and do whatever is here again. So keep on saying hi to them. After you say hi, come back and check. Are you buying something from us? If yes, the moment a person says no, then exit the loop. Do we get this? For the normal while loop, we first of all check the condition before we do the thing. but you use the do while loop when you want to do something before you even check the condition. So I want to execute something. Maybe I should print out a number. I want to print out that number even before I go and check something. Okay, so let's say x is equal to 20. Then print, I want you to print 20 or print x. After printing x, check if x is greater than 10. If it is greater than 10, then you don't do anything. Or, okay, let me say if it is less than 10. Please, are you getting the concept? So the first thing is that the normal while loop, if this was the normal while loop, we'll start by saying while x is less than 10, do something. Okay, that's how we would have started. But for the do while loop, we first of all do the thing. So do something before we even come down to check if the condition is true. Any questions on that? For the do while loop, the difference between the do while loop and the while loop is that with the while loop, we first of all check the condition to see if something meets the condition before we do it. But for the do while loop, we do something before we check for the condition. And if the condition is met, we keep redoing it. We'll do it until we break out of that condition, then we exit. Okay, so I'll share a practical example later, maybe as assignment for us to try our hands on. Okay. Now, quickly, let me just brush through the concept of functions so that we can discuss it during our next PLD. I think Friday is a PLD, so we may discuss functions, God willing, on Friday. Basically, all we've been doing so far is giving our commands one after the other. I want you to print something. I want you to do this. Okay, but a function is like a set of commands that have been created that you can reuse. So if I say create a function, like in human life, when you tell your computer to print something, it knows what to do. If right now I say unmute, you as a human being, you know what to do. Like, you know what unmute is. That is a function in itself. It's a series of commands that has been put together that you, the human being, understands. You understand that unmute means go onto your laptop or go onto your phone, look for where the microphone sign is, click on it, and it will unmute you. So those are the steps that you take. The commonest example that I always use is walk. If right now, as I'm here, I'm sitting down, if you tell me to walk, I know very well that the first thing I have to do is to get up, then move my leg, move the other leg in that order. Okay, and that is the function walk. So just as human beings, you function, you are able to create functions in your programs. But the advantage of functions is that you keep certain commands, a number of commands, put them together, or even one command, put it aside, and you are able to reuse it. So it makes your code reusable. How reusable it is. Yesterday, you created a function called _putchar, and you realize that throughout your program, you were using putchar. How is that? Because you created that function. You created a function, putchar, and this function does something. It writes something to your standard outputs. That is your screen. That is what you did. Okay, you wrote a piece of code that was kept somewhere, which has a set of information in there or a set of commands in there. And anytime you needed it, you just called it. So I think our first meeting, that was last week or so, I mentioned that those of us on the call right now can decide to create a function for ourselves. We can decide to say that, okay, anytime we come here and we say go, it means that take something, like we are just giving a meaning to it. So let's say anytime we say go, it means that we should open our online compiler and write our names in the compiler. let's assume that's what go means. We have all agreed, okay? So we have agreed. It has been stored in our memory. That's what your computer is doing. The moment you create a function, you are going to store the function in the memory of your computer somewhere. Then anytime you want at all to use that function, so as we have all agreed that Google means go and open your online compiler and type your name there. Now that we are doing this live session, if I tend to say Google, all of a sudden, all of you know exactly what I mean. So you go and do it. Okay, so that is the purpose of functions. All right, that's the purpose of functions. But two important things that you need to know: the functions can be declared inside your actual code that we've been dealing with. So far, we've been working with the main function. So the main is actually a function on it, this void function. So in C, when you are declaring a function, you need to tell it the type of output it's going to bring. So tell us, this is your function that you are going to create. What is the return value? The value that is going to return, is it a character? Is it an integer? Is it an empty? Is it empty or is it null? Okay, you need to explicitly mention it. So void, main void that we have always been using, you realize that it's always likely that you're going to be returning 0, which is an integer. I think there was one task that we were asked to return 1, which is also an integer. So the reason why we would always have to return an integer is because the int declaration here. So for every function, you need to state what type of data you are returning. This goes hand in hand with what you are returning. Then you need to give your function a name. Sorry. You need to give your function a name. So here, this function is called main. This is the function name. It is called main here. Then these are arguments that we give it. Okay. So to declare any function at all, I said that you tell us what you are expecting, what type of data. Okay. So the data type for the return, data type for the return value. You need that. Then you need name of function. Please don't worry so much. This is just a quick overview. God willing, on Friday during our session, we'll discuss more about functions and how to create it. So we are not doing any practical. I'm just doing a quick overview. But anyway, if you still have a question, you can ask. Data type, that's the first thing you want. Then the name, then you pass some arguments. Okay. So for instance, we can decide that, okay, we want to create a function in our program called sum. And this sum is going to return the sum, which is our normal mathematical sum of two numbers that are passed to it. So in the first place, we know that they are numbers, so we expect the return value to be an integer. Okay, so we have int sum. That's a name. The sum is the name. Brackets. We need to pass the arguments here. Please pay attention to the language. This is the language we use. Okay, this is how we call them. They are arguments. You need to pass some arguments in here. Since we said we are going to take two numbers and add, we want this argument to take two numbers. So num1 and num2. But you should also tell it the type of data. So this is an integer, this is an integer. Let me rewrite this. It will be int sum int num1, comma, int num2. Okay, then we'll have our brackets like that. So we have defined a function. Then inside this function, we want to return the sum of, so we want to return num1 plus num2. Meaning anytime, anywhere that we want to use this, we can simply call sum, then pass two numbers to it, say 2 and 3. And this will return 5. Because we've already explained or defined what it has to do what sum does. Sum takes two numbers and adds them up. We have defined it. We could have decided to call this obed. So instead of sum, I could have declared this as obed. Then this means that anywhere I call obed, I will say obed 7-3 like this, and it's going to give me an outcome of 10, because per the definition of obed, it should return number 1 plus number 2. So that is how functions are and how they work. Okay, in C, there is another important thing that we need to know. Oh, I've exhausted the board. Let me open a new board. There's another concept we need to know about functions. That the first part of your function declaration. So in the first example that we worked with, we did int sum, then we said int num1, then int num2. Okay, this part of your function is very important, and in order to be able to use this sum function everywhere you go, it is recommended. This is what we call the prototype of the function. In C, we call this the prototype. So yesterday, a lot of us were confused about this whole thing. This is the prototype of your function. And because the function itself can be in a separate file, you can actually create multiple functions and keep them in separate files from the one where you are going to use it. So assuming we have created a file, or let me use yesterday's example, we created a function called _putchar. Okay, so we created this function _putchar. Then when we are going to use this, we use it on almost every one of our projects. So maybe you are in main.c. You are in main.c and you are using this. It's not inside this file. So what do you have to do? Inside your header file that you are using, you included a header file. It is recommended, or it is required, that you put your prototype inside the header file. Your header file always ends with a .h. So yesterday we created main.h as our header file. So you needed to move this prototype into your header file. The reason is that I keep saying that C compiler will read the code from top to bottom, If C now reads your code up to this point, main void, and it gets inside main void and it sees you using a function called sum, it has no idea what sum is. Even though you have created sum as a file somewhere, you have created the instructions for sum, but this your file that you are working with has no idea what sum is. So in order to tell it what sum is, it has to, you remember that just as we work with integers, if I go ahead and declare a variable here without telling C about it from the top, without declaring from the top, C is going to throw an error because this is the first time he's seeing a variable. You haven't declared it. In the same way, to use functions, you have to declare it, but this time around you declare it above your main, and not just anywhere at all, but it is recommended that you keep it inside your header files. So the declaration, unlike variables that we will just go ahead and say int s, we finish declaring. For functions, to declare a function, you use the prototype. So you should have the prototype inside your header file. So if you don't know what this is, prototype. If you don't know what this is, you can go back to yesterday's assignment, look for your main.h file. Main.h file. You realize that you have a lot of prototypes in there. And basically, I've given an example of a prototype where we have int sum brackets int num1 comma int num2. So Please, this is the prototype we are talking about. And you are supposed to keep this prototype inside your header files. Once it is in there, C will always begin with what? Pre-processing. Pre-processing will process your header file. So it's going to get all the files that you have put in there. That now you have declared sum. So wherever sum is, the preprocessor will go and grab it. So that by the time it gets to your main to read what main is and find out you've used sum there, it already understands what sum is and applies it here. Hopefully during Friday's PLD session, we'll discuss a lot about functions and implement it. There was an assignment during the last session. Kindly, if you are in the group and you've done it, you've been able to do it, you can always share your answers with us. And this one too, I may bring up some examples that will make it practical, but I know there are tasks ahead that we have to do. So focus on the ALX tasks and finish it. If you have any concerns, let's address it now. AOB, address it now before we end the session. Yes.
Okay. This main.h and I don't know main.c. Where do we get the content from?
Okay.
And what are you looking for?
I just need clarity on it. The other time we used the putchar.
Okay.
So I want to find out what is the difference between putchar and the normal printf that we used. That we used to.
Printf. Okay. So let me take the question Orion asks together with Gesto, that the content of main.h and main.c, where do we get them from? Okay. So what you should know is that those terms that we are using right now is just from yesterday's assignment. So it's just because yesterday's assignment required that you have something like that. Okay. Any C program that is running looks for something we call the main function. So for any C program to run, there has to be a main function in there. There should be a main function in there for the C program to run. And the main function we have been using all this while is declared as int main void. Okay. So we have been using all this, this all the time. And we decided to save the file that contains this file and call it main.c. So we could actually have saved it as anything at all we want. But mostly, that's how we end up saving it. All that is important to see is that when I come to this file, will I find this function, main function? Once I can find it, that is all. Then we need header files. Unfortunately, per yesterday's assignment, we were asked not to use stdio, which is the common header files for the libraries that we've been using. Okay, so if I want to go ahead and use functions like printf, what you should know is that this printf that you have been using comfortably is actually a function that somebody wrote. It's a function that somebody wrote to tell your computer that anytime you call printf, okay, and pass something to it, this is how, or this is what it should do. Somebody actually sat down to write it when they were developing the C program or C programming language and said that this is what printf does. Somebody did that for scanf. Somebody did that for putchar. Okay, so all these are predefined functions that we call system functions that we have access to. But you can only have access to them when you invoke this stdio.h. This header file is the one that contains the prototype to all of these. So the moment you ignore this in your code, you can't use printf, you can't use scanf, you can't use putf. The moment you don't have this header file, these functions are not available to you because you've not declared them. So yesterday's assignment told us that we shouldn't add this standard library. Once we are not adding the standard library, it means that we no longer have access to scanf. If you use scanf or putchar or printf, your computer doesn't know them, it doesn't understand them, and therefore it's going to give you errors. The only time it will understand what printf is and scanf is when you have used stdio.h, because that is what it knows. I hope that is clear. For that matter, in order to serve our purposes, we're asked to create our own function called _putchar. That will do a similar thing to what this putchar that we know does. Okay, once we have created this function in some other form, we just needed to keep the prototype of that function inside a header file. Okay, that header file, we could have also decided to call it stdio.h, but it will confuse our computer because already stdio is a header file that is system inbuilt. So instead of calling it this, we could have also called ours obed.h, and that becomes a header file. And all we will need to do in our program is to include obed.h in our program, and it will now understand putchar, the underscore putchar. So that is what we were asked to do yesterday. You have created your file, put the prototype inside the header file, but the question told us that we should call our header file main.h. That was from the question. It told us that we should call our header file main.h. So all that it means is that whichever function you add, so the question kept asking for a number of functions. Oh, create this function that does this row, create this function that prints the alpha letters or the alphabet. Okay, once you have functions coming up that you are being asked to create those functions, then you need to pass their prototype to the header file that you are using, and you have decided to call your header file main.h. So ALX could have decided that we should call our header file ALX.h. In fact, if you check any of the Hobbiton's students, their work, you realize that they call their header file Hobbiton.h. That's how they call their header files. But ALX calls is main.h. That is our header file. So this isn't anything strange. We could have called it anyhow we wanted. What is important is that once you've passed your prototype to it, you need to include it when you are about to write your code. Then the main.c that ALX gave us was to help us test our work, because I've mentioned that for every work that you do, you need a main.c function. So for instance, ALX said you should create putchar as a function. That is all it asks you to create. So you go ahead and write your code. After writing your code, something write. So you return write, then one, blah, 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 something like this. Okay. After you have written, this is just a function, and this cannot be executed. You've passed the prototype of this function into a header file that is called main.h. Okay. So for ALX to execute this function with the checker, they have an inbuilt what they call main.c file, where the main.c file just contains a function main void function. Okay, and inside the main void function, what the checker is doing is that it's printing something using the function that you have created to see whether it will give them the outcome that they are looking for. Once the outcome is correct, you got the output right, so your code is marked correct. But this can only be right if you put your prototype into the header file, And if they also decide to include the header file inside their h main.h. Is it clear? Hopefully when we start doing the practice, you get it better. But I hope this explains it. Okay, so we could have called these things any how we wanted. The important thing is that we should have, if you want to define your function, that is called user-defined function. So there are two categories of functions. We have the system functions and the user-defined functions. So system functions. The system functions, if you want to invoke them, you have to use the standard libraries. There are a lot of standard libraries. stdio isn't the only standard library. It is just one that we are used to because currently all we've been using is printf, scanf, putchar. The moment we start going into some mathematical functions, okay, you will see something like we'll be using maths.h because that's also a standard file, all right? And it's just a header file containing prototype. So all you need is that there should be a header file containing prototype of the function that you are using. I hope I've answered that. Now let me tackle Smith's question. The difference between putchar and printer. So these, as I keep saying, these are system-defined functions. So the functions were created prior to us coming to use C. And they were given specific meaning. It's like saying, if I say walk, you understand what I mean. If I say crawl, you understand what I mean. If I say run, you understand what I mean. Exactly what to do. You know exactly what to do. Even though all of these are forms of movements, they are different forms of movements. So printf and putchar are all functions that helps us output something onto our screen. However, the format they do this and the type of data they can take is different. For printf, we can print almost any type of data. But for putchar, the person who wrote it says that it is putchar. So I want you to use it for only characters. So that is their difference. There are functions that are used to output something, but what they do exactly is different. The printf does something different. It does take in any form of data type and output it. But for the putchar, we always have to output a character. I hope that answers the question. Any other questions or any other clarifications before we end the session? Wow, we've come like 3 hours. That is wild. Yes. Any other questions? All right. So if there are no questions, then
how did you handle the Fibonacci in the last task?
The Fibonacci series and sequence. Wow. Yes. So for a task like that, okay, what you need to understand is what Fibonacci actually is or how we achieve it. And basically what it is for a Fibonacci series. I remember this and we learned it in. So what it is that it is a series of numbers, and for each of the members, the preceding two values will add up to give you the number. So if I want the next number for this, let's say we start with 0. The next number will be 0 plus, there's nothing to add, so it will still be 0. That's how Fibonacci starts. Then, okay, so 0 plus 0. No. I think it always begins with 0 and 1. Sorry. It begins with 0 and 1. That's where it always begins.
Of 0 and 1 are those same exact numbers.
Come again.
The Fibonacci of 0 is 0 and the Fibonacci of 1 is
1. Okay, yeah, sure. So when you take that of 0, obviously 0 plus 0 is 0. And when you take 1, it's 0 plus 1. So that is 1. Then the next one is 1.
0 plus 1 will give 1.
0 plus 1 will give us 1. So we'll get another 1 here. Then 1 plus 1 will give us 2. Then 1 plus 2 will give us 3. Then 2 plus 3 will give us 5. Okay, so this is what you need to understand first before you can even go and do the programming. If you don't understand this one, you won't be able to solve the problem. It is in the same way as when we wanted to check if a number was even and print out the even numbers. We should have known that even numbers when divided by 2 give us a remainder of 0. If you didn't know that, you can't solve the problem. Okay, so for this Fibonacci series or sequence, you need to know what this is. Okay, and once you know what this is, you can easily code them. So there is, let's say, a first number, there is a second number, and the next number is always equal to first plus second. Now that you know this, you can use with the help of the loop to print as many as you want, because you know your first number, you know your second number, and the question that we're given first number to be 1, second number to be 2. So if I want the next number, my next number will be 3, obviously. Okay, but unfortunately, the next number, I can still come and add just the first and the second. So I have to change this. Let's start this. 1, 2. Call a variable first. First is equal to 1. Second is equal to 2. Then we know that our next number has to be equal to first plus second. Okay. If we want to print the first 10, let's assume we want to print the first 10. We can decide that, okay, since we want to print the first 10, let's initialize a value called 0 and use the while loop. Or let me start with 1 and use while loop and say while count is less than 10. It started with 1, okay, so obviously it will be less than 10. While it's less than 10, what I want is that this my next value should be first plus second. Okay, and maybe I want to print out next. Okay, I could, since I even declared it here, I could go ahead and just print next, and this means that the very first time it runs, it's going to print next to be 3. Okay, but before I close this loop, obviously I'm going to increase my count. But apart from increasing my count too, I have to reassign first and second, because now this is the second. We need the next one. So we have something like this right now. Initially, this was our first, this was our second, when we were looking for this next. Now this is the next that we are looking for. Okay, so 2 rather becomes our first, then 3 becomes our second. How do we achieve that? In here, because we printed next, that's why we've gotten this 3. So currently inside this loop, our next is equal to 3. For that matter, we can assign this second to next. This is a bit abstract if we are not doing the practice for you to see, but I hope you open your imagination and see what is happening here. Because inside here, I already stated that my next is equal to first and second. The first was 1 and 2. So next means now next is 3. Okay. Then because now I've printed this next, I have another part of my series, which is 3. So this 3 now becomes my second. So I go ahead and say second is equal to next. Then my first will now be this, but this was already known to be second. So before I even go and, sorry, why is this thing? Okay, sorry. I have to also reassign the value of first before I even come to reassign second. So first was 2. Second was 2. Now I'll pass it back to a variable called first. Then I'll pass the value of next to second. So what I've done here is that when I started initially, f was equal to 1. Then s was equal to 2. Then n was equal to 3. After this step has run, the second step, I've changed it to f is equal to 2, s is equal to 3. Then now I'm going to look for n. So n becomes 5. When I'm done with this one, I'm going to switch them again. F now becomes 3, s becomes 5. Then I look for n. N becomes 8. So this is how we solve Fibonacci. Let me just go over it once more, then we go away. We have been given this 1, 2. So we decide to say f is 1, s is equal to 2. We are finding n. Then we know that n is equal to f plus s. Okay, so we have stated that n is equal to f plus s wherever we find it. So when we enter the loop, the first thing we do, in fact, you can even decide to print it before you enter the loop. But when you enter the loop, you print n, and n is equal to 3. Once you have gotten n, our interest is what to print next is that this value now becomes our second. So we have to reassign the first and the second. Since now we have, let me write them, f is equal to 1, s is equal to 2, n is equal to 3. Now you would do this kind of assignment. But always remember that C reads from top to the bottom. So if you go ahead and reassign S before you reassign F, you'll be wrong. So you have to reassign the first one. You say F is equal to 2, which was S. So you pass the S value there. Then S is now equal to 3. Then we'll go ahead to find N. N is 2 plus 3, that is 5. Then we have to switch again. F now becomes this, S becomes this. So our F now is 3, S is 5. Then this gives us N is equal to 3 plus 5, 8. So we'll go ahead and do the switch again. F becomes 5, S is 8, so S is 8. We go ahead and find N again. N is 13. Do the switch. F becomes 8, S becomes 13. Then we find N, like that. So this is the essence of loops, because now we keep repeating the same thing. So with a while or a for loop, we can get all of these things done. But the problem that a lot of you probably didn't get is how to reassign the variables. Okay, so I said that C reads from top to bottom. Therefore, you always have to reassign the F before you reassign S. And all you are doing is that here, from this step, all that I did was that I said F is equal to S, then S is equal to N, then N is equal to F plus S. That is all. So just use this formula inside your loop, and you are going to end up with a Fibonacci series that you were asked.
Sorry, I have a question. So
all right,
whatever variable we assign, we have to add less than equal to 100. So it stops at 100, right?
Yes, that's in your loop.
Yes.
If you're using a loop to check whether, yes, that's how it has to be. But one thing that you need to pay attention to, that question was a bit tricky. The one that said we should print the first, is it 98 or something, was a bit tricky because they were asking you to use, don't use long, which I think the only one we're allowed to use was long integer. Okay, and just as you might have seen or heard by now, these ones have a certain size that they can contain. Beyond that size, they begin to give you wrong values. So if you do the Fibonacci sequence up to around 90 something, I think, is it around 92 or so, you begin to get errors. The addition do not match up if you are using the long integer or just integer, because the values cannot be contained. So you have to find a way around it. Therefore, if you go and do up to 100, your value that you'll be getting at the hundreds will not be right. Okay, but we'll have to take our time to go through that. In fact, I created, if you saw my replets, I created a replet trying to explain how I did it. Okay, let me see. I could possibly share the link to that replet.
You explain.
I've done the first two. The the video is very long right now. I need to cut now because I'm going to upload this video and data and everything. But I think we'll probably have to find time that we'll use specifically to discuss the tax. Then we'll find time where we come to learn concepts and understand the application. Okay, I think we have to do that. That will help, so that we know that today when we are coming, it's just the tax. We take them one by one, explain them, then tackle all of them. Okay, so this is the Fibonacci one that I did.
Repo it.
Come again. Sorry, I didn't hear that.
You can send the link to that repo it.
Okay, I'll share the link to it. All right, so this is what I did. Okay, it's just the reassignment that is important here. So it's very simple. I went ahead to print. In fact, I think I've even updated this one. I think I've updated it. But for now, let's just see this. I went ahead to print the first two digits because we've been given those ones. Once I print the first two, I enter the loop to check whether we are still under 50. If this one is not important, these if statements here are not that important. They are just to help us put the the commas rightly. Okay, they are checking so that the last one we don't put a comma there. So it isn't the most important part. We could have ignored it and just printed our value. Then once we have printed the value, we come to, let me comment this one out. All that we're doing here is printing the next value. Okay, the value for next. Sorry, I hope you can see my screen. Okay. Yeah, so that is all I was doing in here. I've already defined next to be first plus second. Okay, so when I come here and I print next, it's going to print 3. Then I come and I do first is now equal to second. Second is now equal to next. And next is equal to first plus second. That is what I've explained using this concept. Okay, so simply, this is how it goes. No long coding for you to get the Fibonacci one. All that you need is the understanding how they come by before you get. As for the last one, I'm yet to get the final part. The latter part, I'm still trying to figure it out how to explain that. So I can't share that. Yes, goodness. Goodness, were you going to say something?
Hello, can you hear me?
Yes, boss.
Okay, my aside this one, that we're working on, the debugging task.
Okay.
I understand that there were no details as to the errors that came up, so they expected us. ALX expects us to debug by ourselves.
Okay.
And in as much as the task has been done, many of us were not able to pass that error point. So how do we? What can we do to problems?
Okay. All right. I personally haven't tackled any of them yet, so I don't know exactly what it is. But as I said earlier, when it comes to debugging, the first thing you want to master is you using your eyes to debug. Okay, because there are times that the compiler or interpreter to whichever programming language becomes silent on an error. And there are different types of errors. Usually for syntax error, your compiler or interpreter may give it out to you that, oh, there is a syntax error here. But sometimes it is. Can you hear me? Hey, where is that?
I can hear you. I can hear you.
Okay, someone is talking in the background. All right, sure. So, well, what I'm saying is you have to train your eye to be able to spot errors. The reason why this is important is that there are times that the compiler or interpreter or whatever IDE that you are using will go silent on the error. And if you do not have the eye to pick it up, then it means your program is going to go into production before users realize that this software is giving me wrong values. Okay, so that is what they are trying to help us do right now, train ourselves to pick up errors. So I can give you an option that can easily help you get those things. But the first thing I want to tell you is that let's try as much as possible to pick the errors with our eyes, okay? Except for the fact that this task is time bound and you need to submit within a period of time. So for instance, if you want to know what the problem is, just come and use any of the online compilers. Compile it. If there is an error, the compiler will tell you what the error is. But I was saying earlier that there are different types of errors. For instance, we have logical error. With a logical error, it has to do with the logic of your program. Let's say this Fibonacci one. I say that if you do up to 100, the latter part will not give you the right thing. It won't come out as an error. You would have to go through. In fact, today I spent a lot of time before I realized that that part wasn't right. Okay, so you would have to go through it before you pick up logical errors. All right, but let's start training our eyes to pick up errors. And even when the console gives us the error message, we should also try to learn what the error message means. So you can use Replet. Replet, if there is an error, will tell you, let me delete this one and run it. You see, so it's telling me that line 37, second character, error, expected identifier or this. So there is an error there. Then line 38, error, extraneous closing brace. So something like this, okay, over here. Just telling you that. So you can diagnose your problems using the online compilers. The same way if you use Python, if there is an error, you will be able to pick the error. So you just copy your code here, then check it. But my advice is that first of all, try going through it your eyes and see if there is any error line by line. The same way the compiler works, from top to bottom, left to right. You to go through it top to bottom, left to right. This line, is it correct? Is there anything I'm missing here? All right, let me check this line. What about this line? Go through it. When you are certain that you couldn't pick out any error, then run it with any of the online compilers and check. As I said, I have actually not done it because so I don't know if what I'm saying would help, but hopefully it helps. And by the time I go through it, I'll be able to inform you better on it. So if anything, I'll share the information around. Guys, I think I'm tired. Like, I've exhausted myself.
Thank you.
Sorry.
Yes, goodness.
Doctor, next time.
How come people are talking and I can't even hear them?
Hello, can you hear me?
Please, I'm taking only goodness.
Yes,
goodness.
Hello?
Yes,
Okay, so I
goodness,
wanted
I
to
can
ask.
hear you. Goodness, I can hear you.
Okay. I wanted to ask because when you opened your GitHub, I saw that this thing you used was 50, the count for that Fibonacci.
Oh, okay.
The count was 58.
Someone is talking. I can't even hear the person.
It's 50.
50. Hey, why didn't you use the 98?
No, this one is the very first one. There was, the Fibonacci, there were 3 questions. So this is the very first one.
Okay.
Yeah. Okay.
Thank you very much. Thank
You're
you
welcome.
so much. I've learned
and thank you all too. You're welcome. So I'll try and video, then upload it to YouTube for reference sake. Because even myself, sometimes I have to go back and revise so that we'll always have access to it. Especially for the fact that sometime from now we won't get access. When we are done, we won't get access to our intranet. So we'll keep records of these things so that anytime you meet some of such problems, you remember that, oh, this one we even discussed this problem. Okay, so let's do that. And least I forget, we had an assignment on BMI. Please think through it and solve it. Okay, problem solving is very important. And I keep saying that you don't need to solve a problem only when you are sitting behind the console. Solve it in your head even before you sit behind the console. So in as much as we are busy going about our things, we should still find some time to think. All right. Hopefully we'll meet again on Friday. On Friday, PLD. And before Friday, let's try our best to do our work. And if you are done and you have time, try and help people. And those that need help too, please, the earlier the better. If you mention it early, at least somebody who has done it. It's not everyone, even though sometimes they have done it, but they didn't face the problem you faced.
No, not again.
I can't hear what people are saying. Is it only me? Am I the only person?
No, I think Obed network
It's general.
was
It's
bad.
network.
Network don't fly.
Okay.
Network has been bad.
Okay, you just sent a message that is light.